All right, guys. So we are moving on to section 9.2. Section 9.2, there's two parts. The first part is rotation. The second part is dilation, okay? So for rotations is just a turn. So you're just turning the object, all right? So it's just a turn around a fixed point called the center of rotation, okay? So we have an object and we're just rotating it around the center, okay? So the figure rotates at a specific, and this is where we kind of get into some math lingo. So a specific angle and direction, okay? Specific angle and direction. So if you look over here, it's rotating at this angle, all right? And it's rotating toward the left or in a counterclockwise direction. So we're going to use counterclockwise and clockwise when we're rotating, okay? So the rules, and this is where, guys, it's not too difficult and you don't need to be like counting on a graph, anything like that. We have a rule as long as you, and this is where what I'm going to fill in this box right here, okay, in that box right here, all right, the 90, 180, 270, please have this written down, all right, somewhere for you guys, because that's the important part. These are the rules. As long as you have the rules, you should be fine. And honestly, you probably don't even need to graph it, but it's a good way to check yourself, okay? So this one, rules for rotating counterclockwise. So if we have a clock, all right, so 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we have a clock, all right, this is what you want to think about. Rotating counterclockwise, all right, is that way. That direction is counterclockwise. All right, counterclockwise. Now, if we rotate the other way, we are going in a clockwise direction, just so we understand the difference between the two, okay? So think about a clock, think about which direction are we moving. Typically, I think for all the problems, they're going to be counterclockwise. They're going to be rotating to the left, if you want to think about it like that. Counterclockwise goes to the left. So think about a clock and going counterclockwise. The origin. So we're rotating counterclockwise about the origin. The origin is just the point on the graph at 0, 0. Okay, just a reminder about that. So if we're rotating 90 degrees, think about a right angle. Okay, so we're rotating 90 degrees. If we have the coordinate, and this is where if we have the coordinate x comma y, so this is saying for any ordered pair that we have, if we rotate that coordinate 90 degrees, it's going to have the new coordinate of negative yx. Okay, so I know we're using variables. I'm going to put an example underneath it. So if we have the coordinate, I'm just pulling this out of the thin blue sky. Okay, so I'm just making this up to make it easy on us. So if we have, so this is just an example here. We have the coordinate 4, 3, okay? And we rotate it 90 degrees. The new point, all right, that we're going to have is going to have the ordered pair of, and we're going to take this 3 and move it to the first position and make it negative. So we're making it negative 3, and 4, our x coordinate, goes to the second position there, and we have the coordinate negative 3, 4, okay? Now, for rotating 180 degrees, so think about like a straight line has 180 degrees in it, okay? So this is being turned in the other direction, all right? Turn 180 degrees. So for this one, again, going to have just the generic x, y. If we rotate it 180 degrees, now all of a sudden that becomes negative x, negative y. Remember, we say put that negative in front of it. Basically what it means is we're changing the sign, okay? So again, for our example, if we have the ordered pair, and I'm just going to pick 4, 3 again. We're just going to stick with that. It becomes negative 4, negative 3, okay? So that's what it's changing to. So we're just making both those values negative, okay? All right, so for the last one, it looks like we'll have to finish it up on the next video.